Good evening, everyone, respected dignitaries, dear mentors, and all my dear mates. So, we team Ragnarok from Haldia Institute of Technology, Haldia, West Bengal, consisting of team members me, Hore, my teammate Aayush Dutta, and our mentor, Professor Priyatosh Jana, are over here to present our solution based on the problem that is benchmarking of IDS and IPS. So what our problem statement describes and what RFC it includes. Our problem statement is benchmarking tool for the IDS, that is intrusion detection system, and IPS, that means intrusion prevention system. It was stated in RFC 9411. And the RFCs that were involved, previously RFC 3511 was doing the benchmarking one, but only for the firewall versions. But the new RFC that is we are working on, that is RFC 9411, it deals with the benchmarking of IDS and IPS that comes before the firewall sections. The other RFCs that are RFC 2544 that measures the performance. Actually, this is the benchmarking methodology. And the RFC 6349, it deals with the TCP. TCP means Transport Control Protocol. It gives the TCP relay part. Later, my friend Aayush will be discussing what approach we have done to solve this problem and other sections.
Okay, so the method we have used is, first of all, we need to have IDS to benchmark it. So we prepared a test environment where we can replicate all the scenarios which were mentioned in the RFC. The RFC specifically mentioned that the IDS must have some specific rules which we should work on. So we used the Surigata IDS, which was very easy to configure, and we configured it with all the rules that were mentioned in the RFC 9411. And secondly, the previous RFC, which my friend talked about, RFC 3511, it only dealt with firewalls. The new RFC 9411, it deals with firewalls as well as IDS and IPS. So the next generation intrusion detection systems. Now what we did is, first we had our test environment and we needed a traffic generator. We need both type of traffics, a real traffic like browsing web and everything, and also a malicious traffic. Malicious traffic, which is specifically mentioned in the RFC 9411, that the previous RFC didn't have support for the malicious traffic. So how to benchmark next gen intrusion detection systems? So they included the malicious traffic. For this we are having some specific PCAP files, and it is here mentioned that TCP, we will use TCP replay to replace some malicious traffic, as well as I will be performing a DOS attack on the IDS and benchmark it accordingly. Then after this we will do the traffic analysis and everything will be fed on the IDS. Now however the IDS will perform, it will be shown in our performance metrics, which is a web-based dashboard. So what we got done? Finally, through the hackathon, the period of the hackathon, we have prepared a web dashboard. It was exclusively mentioned throughout the hackathon that we have offline online that we should go for the web-based dashboard. Initially we were having a CLI-based dashboard, CLI as in console, but then we switched for web dashboard because our mentors suggested it, and it was a better technique to show the results. The CLI does not have the facility to update everything at once, so the web dashboard was absolutely better. Then later on we have also made the design a bit responsive, and we have benchmarked the IDS IPS based on its CPU, memory, network throughput and the latency. Okay. So the technology stack is very simple, like we have used Kali Linux as OS. The performance metrics, everything is coded in Python and Flask. The IDS and IPS, I have mentioned that it is Surigata. And the file types involved are PCAP files. PCAP files are basically packet capture files. What are packet capture files? If you are having some malicious traffic or any type of traffic, you can record them and keep them, and you can replay it if you need it. So we have some PCAP files which have some malicious traffic. Then there is JSON involved. JSONs are JavaScript objects which the Surigata uses for generating the alerts. We have logs, we have CSV, Python, HTML and JS. So what's the output of this? So in the screen you can see that we are having a benchmark web framework where we can see that it is having the CPU usage, it is showing the memory performance, the network throughput and latency. Along with that, we have also integrated the system for showing the alerts and also a button which will show the benchmark results, which I will see right now how it works. So as you can see, the whole web dashboard is live and I have already activated it so that I have no hustle about it. So you can see that everything it shows here: the CPU usage, the memory usage, the network throughput, the network latency that the Surigata IDS is facing right now. It also shows the alert. When I perform some attacks, it showed that what kind of attack it had. It was a low priority attack or a high priority attack. What type of attack was that, from where the attack was generating and to where the attack was going. So it was all mentioned in the alerts log. Now let's do one thing. Let's benchmark the IDS in front and see how it performs. So let's first go to a website to generate some real traffic and let's see how is it performing. Okay, so see, the throughput is increasing. Of course it must increase since it's a regular traffic, and the latency was spiked because we just visited the website and all the HTTP traffic was captured for a second. The CPU usage has increased but not much. It is just 3%, and I guess it is just giving, the internet is just giving us 40 kbps, and so there must not be a big throughput. As we can see, I guess it has spiked. Yes, 5.6 Mbps. So it spiked as well as the throughput spiked. So the real traffic analysis is done. Let's go for some attack traffic. Wait. So for the attack, I am using another VM to generate a real-time attack. And now the attack has begun. It's a kind of a DOS attack, as mentioned in the RFC, that we must mention a DOS attack. And we can see the CPU usage has spiked. There has been some network latencies, and the latency is spiking, and it has spiked a bit much, and it has spiked to 25%. We can see that it is working. Okay, now let me stop the attack. Okay, so let's see some benchmark results. So here are some results. So these 568 or 514 what we are seeing is just normal traffic. Like when we are using normal traffic, the HTTP connections per second are just 514, which should be normal. Then the HTTP throughput is in Gbps, so it's 0.03976, and the latency is very less, 191 milliseconds. And the concurrent connections we are using for this benchmark is 100 concurrent connections, which is I guess relevant for a real-time perspective. But when we are going to the attack scenario, we can see the HTTP connections decreased to 208, and the throughput also decreased. It decreased by half. The latency spiked by double, more than double. We can see it's 474 milliseconds, and we were using the same type of 100 concurrent connections. And we have the timestamps here. So this is how our whole, and even you can see the alerts. We can see the time. It's the time is wait. So we are having the time. So we see that there were some potential corporate privacy violation, DHCP request packets. So these are high alerts. And even I can generate some more malicious traffic to see that it is valid or not. So let me generate some more malicious traffic.
This is the PCAP one we are using, PCAP file one for capturing context.
So let's see if we get any new alerts from the. Yes, we can see that there is some low alerts. The low alerts new by at 440. You can see that it is working properly. Let's see if there are some more alerts coming, by the way. There are some a network trojan was detected. So we can see that the Surigata IDS is working fine, and we have benchmarked it successfully.
So
So the work was, before coming over here, the work was totally on CLI based. After coming in 2 days, we created the total web dashboard as well as the alert functionality within 2 days. So the future works involves making the benchmarking tool compatible for hardware devices. Also, we'll make the UI UX which we have seen responsive type. It is normally a dashboard functionality only possible for laptops, but we are making it for mobile devices also. A benchmarking summary report will also be logged in. So what we have learned through. Before starting, I would say that we have gone through the RFCs, that is 9411 very specific, and what RFC 3511 was making being absolute, and new RFC 9411 is coming. We totally read through whole steps, and also we have learned through the various internet standards. Later, we have evaluated the IDS and IPS, the Surikata one. We have evaluated its performance. Also, we have recognized the importance of diverse and dynamic packet analysis for robust evaluation. We are doing it on a real-time basis, the evaluation one. And at last, we have acquired hands-on experience configuring and testing the IDS and IPS in real-world scenarios. So that's all our presentation all about is. Thank you. Any questions, sir?
I'm just curious about one thing. Okay.
Yes,
You have very fantastic monitoring and you have done that
Yes.
real time. That was really a fabulous thing. I appreciate that. See, there are situations where I have maybe a real situation where internally there are a lot of high usage for some batch running or uploads, which are not an attack, but maybe an abnormal situations which is a normal activities. So if you can trace back the sources of this and detect why the high usage of CPU or high usage of this are caused by an internal process with maybe abnormal, it's not a normal, but nevertheless it's an internal process. Vis-a-vis an external attack, which has an intent to make it.
Yes, sir, it's a fabulous question. So what is that, sir? What we are dealing with is any IDS or any IPS. So they work on some rules. If you don't configure the rules, it will be just a software which does nothing. So if we are having some heavy batch processing or doing something like that, we just need to mention the ideas that there is a specific task like this. Don't consider this as a Trojan or any malicious activity.
But I am not aware of the timing of this task. I just know this type of task might come. But
so what we can do, sir, we saw that in my web dashboard there are some alerts. So there are some alerts which are labeled as low. There are some alerts that are labeled as high. The high are literally malicious because we can see a network Trojan was detected. But in the low one, we can see that it's just some are just Unicode shared access are taken or something like that. So if this is just a batch process, it will be definitely considered as a low level of attack. So
how do you know? How do you know? Can you attach some kind of a pattern that okay, if this type of activities happens, you ignore that as an internal thing. Otherwise, they will know that a high usage means this is an abnormal thing, right? Nevertheless, whether it's a normal.
Sir, high usage can be from anything. Like
Yes.
if I showed that if I do like I am doing regular internet access, I'm playing.
I agree to your high alert things, but I said whether it is malicious or not, how do you detect whether it is intentional or it is a natural thing, right?
Yes, sir. That malicious part is always done by the rules of the IDS.
So you have
Rules.
permission for
The rule
the
set we discuss in the Surikata that handles the total malicious, whether it's malicious or not.
so you detect the source and other.
Yes.
Yes, sir. And the rule set is actually given at the RFC 9411, and we have performed it
Yeah. So
like that.
Yes, sir.
that is exactly my question. Thank you.
Okay, sir. Thank you.
Any other questions?
Thank you.
Thank you, sir.
Thank you. I think this is the last one, right?